Hi guys, as I said before, in this video we're going to start discussing on probability distribution, which is the gist of this topic. However, before probability distribution is defined formally, we need to define one thing, which is variable. We need to review it again. So in chapter 1 before, a variable was defined as a characteristic or attribute that can assume different values, variety of values. So we can also say that variable is the things of interest, right, that we want to look at in our experiment or in our observation. So that is a variable. Okay, so in terms of representation, various letter of alphabet, usually capital X, Y, or Z, are used to represent variables. Okay, we use probability to measure numerically outcomes of a random experiment, and recall that random experiment, the terms random experiment, is an experiment whose outcomes are not predictable. Right, the keywords there is not predictable, which is equal to random. So the following is a definition of random variable. So basically, random variable is a variable that comes from random experiment, and this is the definition of random variable. So random variable is a variable whose values are determined by chance, right, for each outcomes of a random experiment, and it is also usually denoted by capital letter X, Y, and Z. So for example, if a die is rolled, a letter such as capital X can be used to represent the numerical outcomes of that experiment or random experiment. Therefore, the value of capital X we can assume are 1, 2, 3, 4, 5, 6. Right? X equal to 1, 2, 3, 4, 5, 6, which correspond to the outcomes of rolling a single die. If let's say we are tossing 2 coins, and we put later, let's say, capital Y, right? We can use capital Y to represent it, right? And we want to use it to represent the number of times a heads occur when you're tossing 2 coins. So in this case, we can say that Y equal to, when you have tail and tail, that is 0 heads. If you have maybe head or tail or head when you're tossing 2 coins, that is 1 head, so 0, 1. And that's also possible to have head and head, so that is 2 coins. So Y is equal to 0, 1, or 2. In other words, a random variable X is a function that assigns a number to each outcome in the sample space, right? So notice that we use capital letter X and Y to denote the random variable, and for all the possible values, we use lower case letter of X and Y. So that is how we write it down, right? That is the sample space of a random experiment. So in probability distribution, right, we also have, just now we talked about random variable. Now let's look at the definition of a more specific random variable, which is we have discrete random variable and continuous random variable. So what is discrete and continuous random variable? Right, these two names are actually based on the data that they are having. So we have discrete and continuous data. So for discrete data, when we have a random variable, it is discrete random variable. So basically it is a random variable that can assume only countable number of values, which is 0, 1, 2, and so on. As for continuous random variable, it is a random variable that takes a value at any point along any interval. So basically we can say that from 0 to 1 or from 1 to 2, there will be a lot of value there because there are a lot of points in the middle. So continuous random variables are obtained from data that can be measured rather than counted. That is the key word there, right? Measured and counted. So measurement is required to determine the values of random variable. So to be more clear on these two types of variable, let's look at this table. So there is an example, several examples of discrete random variable which is countable, right? We have number of sales, number of calls, number of questions, people in line, mistake per page, number of defective items. All of the things that can only be counted and not measured, right, is discrete random variable when you use it for your experiment. As for continuous random variable, we have length, depth, volume, time, weight, and also daily rainfall. Notice that all of these random variable, right, has a value that can be measured in decimals. Okay, so that is the general idea of probability distribution. In our next video, we are going to discuss more on discrete probability distribution and continuous probability distribution in detail. Alright, till then, thank you and bye.